So we've been talking about factoring by grouping and finding GCFs, and we're going to take a second today to go ahead and put together a real final set of notes covering this topic. So let's pull out our notebooks and let's really figure out what needs to be in there so that we can succeed at learning how to do these and having a pattern. So there are really sort of 5 steps that we've talked about over and over and over, and this is what those 5 steps are. Number 1, you need to ask yourself, does your problem have a GCF? And that's talking about the entire problem overall. If you get the phrase 2x cubed plus 4x squared minus 6x plus 18, it should be pretty obvious that the numbers 2, 4, 6, and 18 can all be divisible by 2 so that there is a GCF in this problem. And you need to pull out that GCF, and remember, we always end up with GCF times what's left. Secondly, you need to group what remains so that each group has a common factor. In that previous example, we would have ended up with 2 times x cubed plus 2x squared minus 3x plus 18. And when we talk about grouping, you just need to figure out what will match. Right off the front, if you boxed out x cubed and 2x squared and negative 3x and 18, you'll notice that the front set both have x's and the back set can both be divisible by 3. So again, we're just talking about grouping everything that remains so that each of these groups has a common factor. Next up, we need to go ahead and factor out that GCF. So in this case, we would have 2 times x squared is our GCF for the first section times x plus 2. And we would subtract from that 3 times x plus 6 in this case. Now, as you're looking at this, something shouldn't look right. And that's what comes in on stage 4. Does what's in the parentheses match? In this case, x plus 2 and x plus 6 don't match. But the thing is, that's okay. It really just means that in this particular problem, there isn't something that can be factored. This problem is not factorable using factor by grouping. You won't run into any of these in what we're doing right now until we learn how to deal with these. But the final thing that you would do if this problem worked out is factor out that GCF in the parentheses. Because when the parentheses match, this and this would be the same, so you can pull it out. And once again, you end up with GCF times what's left. That's the big phrase to remember, because that's all we're doing over and over and over, is pulling out the GCF and we're multiplying it by whatever is left over. So make sure that that's one of the key things that you remember, GCF times what's left. So let's look at a couple of examples. So on the right, I have my example problem, x to the third plus 7x squared plus 2x plus 14. And on the left, I've got this nice little set of reminders as to how do I do this. So let's start digging through it. Number 1, does the whole problem have a GCF? If so, pull it out and get GCF times what's left. So to figure out if something's got a GCF, the first thing we need to do is figure out the factors of each of the 4 terms. So let's take a moment and do that. When we're looking at factors, we just really need to think about what goes into it. So for our first term, x to the third, we know that our coefficient is 1, and the factors of 1 are 1 times 1. We also know that there's x, x, and x. Our second term is 7x squared. The factors of 7 are 1 times 7. Those are the only things that multiply to get 7. And we have x and x. Our third term, 2x, if we look at our factors of 2, we know that our factors of 2 are 1 times 2. Those are, again, the only things that can multiply together to make 2. And we have a single x. Our very last number, 14, we can look at its factors and say that it's 1 times 14, or 2 times 7, and those are the only factors. And you'll notice there isn't an x term. So let's sort of look at, is there an overall factor for the whole problem? You'll notice that numerically the biggest factor is a 1, and there is not a common variable factor because the 14 doesn't have an x term. So for this problem, there is no GCF. Since there isn't a GCF, let's move on to step 2, where we have to group what remains so that each group has a common factor. So looking at our factors that we just pulled out, I can see that there are a couple of options. We could pair up x cubed and 7x squared because they both share x terms, or we could go and we could pair up 7x squared and 14 because they both share the number 7. We could also look at a different way of doing it and pair up x cubed with 2x because they share an x term. And there are several other ways we could group it. But the fact is that it doesn't really matter how we do it, they're all going to come up with the same answer. So in this case, I'm going to go with my initial thought, which was to pair up x cubed and 7x squared, and then 2x and 14. So I'm going to move over and write this down on the left-hand side just to keep it out by itself. So my pairings are x cubed plus 7x squared plus 2x plus 14. Now you'll notice something, that I've set a pair of parentheses in here, so it kind of looks like multiplication. But remember, it's not. This plus here is just reminding you that you're adding the whole thing. I'm just putting those parentheses in to help me group it. So let's factor out each group's GCF. So we'll come back to our initial set here and look at what do these share. They obviously share the number 1, and they also share 2 x's. That is, both of them have a number 1, and both of them have at least 2 x's. So my GCF will be 1x squared. And since we're always looking at GCF times what's left, we just need to divide. X cubed divided by 1x squared will give you x to the first power. That's x to the 3 minus 2 power. 7x squared divided by 1x squared will give you 7. That is, 7 divided by 1 gives you 7, and x squared divided by x squared goes away because it's equal to 1. So for my next problem, we'll look at 2x and 14. We can see that right off the bat they share the number 2 as a factor, and they don't share any x values. So we can factor out a number 2. 2x divided by 2 gives you just x back. 14 divided by 2 gives you a positive 7 back. And so we factored out each value. So step number 4 asks us, does what's in the parentheses match? And if so, we're doing it right. Check mark, check mark. They both are equal to x plus 7. So we know we're doing something right. So I'm going to rewrite the problem just a little clearer. It's x squared times x plus 7 plus 2 times x plus 7. And at this stage, we've arrived at step number 5, where we have to factor out the GCF in the parentheses and combine what's left. Once again, we're performing this same task of GCF times what's left. If you look at this line, you can tell right off the bat that x plus 7 and x plus 7 is a common factor between the term on the left and the term on the right. So we are going to go ahead and factor it out. X plus 7, our GCF, will be multiplied by what's left. If we divide x squared times x plus 7 by x plus 7, this goes away, and we're left with what's left of x squared. The same thing happens on the right. 2 times x plus 7 divided by x plus 7, our greatest common factor, will cause this x plus 7 to disappear and become 1, and we're left with a positive 2. So in this case, our final answer is x plus 7 times x squared plus 2. And remember, the easy way to check these answers is to go ahead and multiply them out. For example, if I wanted to use the box method, I would simply put x and a positive 7 on top, x squared and a positive 2 on the left-hand side, and start multiplying. X times x squared gives us x cubed, 7 times x squared gives us 7x squared, 2 times x gives us 2x, and 2 times 7 gives us positive 14. I can now look at these four values and then compare them to my original problem. If the four values in my box match the original problem, we know we've done it correctly. Let's do one more example that talks about having an overall GCF. So once again, we've got the same setup. I've got my rules right over here on the left-hand side, and I've got my example problem here on the right. So step number 1. Does this problem have a GCF? And if so, we need to pull it out. So let's think about what the factors of this entire problem are. So for 6x to the 4th, our factors are 1 times 6, 2 times 3, and we have 1, 2, 3, 4 x's. The factors of negative 4 are 1 and 4, 2 and 2, and we have 1, 2, 3 x's. The factors of 12 are 1 and 12, 2 and 6, 3 and 4, and we have a single x. And our factors of 8 are 1 and 8, 2 and 4. As we look at these, we should see that right off the bat, we share a common factor. In this case, that common factor is the number 2. So we can pull out that number 2 as a GCF and get, once again, GCF times what's left. So I pull my GCF out and I start division. 6x to the 4th divided by 2 gives me 6 divided by 2, which is 3, and my x to the 4th stays the same. Negative 4x cubed divided by 2 gives me negative 2x cubed. 12x divided by 2 gives me positive 6x, and negative 8 divided by 2 gives me negative 4. Our next step will be to go ahead and group it so that each group has a common factor, which is step 2. So once again, looking at this, I'm going to just jump out on a limb and think back to what my original factors were and what was shared, and notice that my first two terms share x's, and I'll notice that my last two terms share a common factor of 2, because 6 and 4 can both be divided by 2. To double check this, I could go ahead and write out my factors, which is a great way to figure out what matches. So let's do that. My factors of 3 are 1 and 3, and I have 1, 2, 3, 4 x's. Factors of 2 are 1 and 2, and I have 1, 2, 3 x's. Factors of 6 are 1 and 6, 2 and 3, and I have a single x. And my factors of 4 are 1 and 4, and 2 and 2. So now I can see exactly what to pull out. In our first term, we share a 1 and we share 3 x's. For my second pair, I share the number 2 and I don't share any x's. So let's start pulling it together. First of all, we're going to carry down our original GCF of 2. And now we're going to start pulling out the GCF of our two interior terms. So our first GCF is 1x to the third, or just x third. 3x to the fourth divided by x to the third is going to give us 3x as a result. And negative 2x to the third divided by x to the third will give us negative 2. For our second term, we know that our common factor is 2. 6x divided by 2 will give us 3x, and negative 4 divided by 2 will give us negative 2. So that completes step 3, where we factor out each group's GCF. And now we ask ourselves the simple question of, does what is in the parentheses match? And we can see that yes, both sets of parentheses contain 3x minus 2. So let's factor that out and combine it with what's left. Once again, that pattern of GCF times what's left. So I'm going to move right up here. I'm going to carry my original 2. Remember, nothing's changing about that. We're just moving it along with the problem. I'll factor out my new GCF of 3x minus 2, and I'll multiply that by whatever's left. In this case, if you take 3x minus 2 out of the first term, you end up with just x cubed. And if you take 3x minus 2 out of the second term, you end up with a positive 2. So my final answer is 2 times 3x minus 2 times x cubed plus 2. To test this one, we'll go ahead and do the box method again. So 3x, negative 2, x cubed, positive 2, and we'll multiply out. So we get 3x to the fourth, negative 2x cubed, 6x, and negative 4. But now if we compare it to our original problem up here, we notice that it doesn't quite match. And that's because we haven't dealt with our 2 GCF. So what we have to remember is that this entire box needs to be multiplied by 2. If we go ahead and do that, we get slightly different answers. We'll get 6x to the fourth, negative 4x to the third, 12x, and negative 8. And those do match our original problem. So in the end, there's really only one set of things that you need to remember to do, and that's these 5 steps. But every step is basically the same thing. It's find a GCF, pull it out, and multiply it by what's left. So GCF times what's left is what you have to remember, and that's all that it really is finding GCFs over and over and over until there aren't any more common factors to pull out of the problem. So GCF times what's left in these 5 steps is exactly what you have to know and what you have to be able to do.